Everyone. Sneha from the Web3 Compass, and this is day 24 of 30 days of building with Solidity. Thank you so much for bearing with me for 24 days, just 6 more days before we wrap up the entire campaign. So make sure that whosoever is watching this video, you drop in your suggestions in the comment section about what kind of content would you want to see on our YouTube channel, what is the next campaign that we should do, be it Web3, be it AI, we are open for it all. For everyone who is not aware about what this campaign is, head over to web3compass.xyz, or you can go watch our day 1 video. That is where I talk about the entire campaign in detail. So when you click on this section, this is the calendar page. This is where you can get all the information about everyday challenges. And today we're going to write DecentralisedEscrow.sol, talk about escrow services, conditional payments, dispute resolution. As an example application, we will build a secure system for holding funds until conditions are met. You will learn how to manage payments and handle disputes. It's like a digital middleman for secure transactions, demonstrating secure conditional payments. Okay. So as of now, yesterday we were talking about the lending pool. We were talking a bit about the DeFi section, right? And now, as this is a part of real world applications, what we are building today is something real, something practical, something that could literally be used in real world marketplaces, which is an escrow service. So everyone who's not aware about what an escrow is, let me just talk about it a little bit in layman terms. So if you've ever bought something expensive online, maybe a freelance job that you did, a second-hand gadget, or a ticket, you've probably wished there was some middleman to hold the money until everyone's happy. That's what escrow is all about. In real world, companies like PayPal or eBay do this for you. They hold your money until the item arrives. If this goes wrong, they step in. But in Web3, we do not need these companies. We can code the middleman and make it trustless. So what we're building today is a simple escrow implementation. So it holds ETH until the buyer confirms delivery, lets either party raise a dispute if things go wrong, allows a neutral arbiter to step in and resolve issues, has built-in timeout logic so the buyer isn't left hanging forever, supports mutual cancellation if both parties agree to call it off. So there's no paperwork, no waiting, no shady third party, just clear rules written in Solidity. Now, the project teaches you how to use enums. We've already talked about enums before. In order to manage contract states, we are talking about handling timeouts. You've used block.timestamp endless times now. Implement a dispute resolution workflows and using modifiers, checking conditions through require for very, very strict access control, right? So yeah, let's just get started. Okay, what all are we supposed to do? So we will just create a new file. We will say a simple escrow.sol. Great. Yeah, it's already zoomed in. I will copy this. Close this. Oh. Contract. Simple escrow. Okay, great. So now, as we all know what we do first, it's setting up the variables and getting around setups. Maybe talk about state management, blah, blah, blah. So as of now, I've already talked about 3 possible people involved. There's a buyer, there's a seller, there's an arbiter, right? So we're saying address, public, immutable. Again, we don't want this to, change. Buyer. Just copy this. So we make this seller and we make this arbiter. right? So buyer is the one sending the money, the seller is the one delivering goods or service, the arbiter is the trusted third party who resolves dispute. Now, what we're going to do is write the state management. That is where enums come in. So there could be possibly multiple state that we can talk about. Yeah. So let's say, okay, I think we talked about in the decentralized lottery system that the lottery is open. So there's one state which is open, there's the other stage which is closed, and the other stage is calculating, right? So similarly here, we're saying awaiting payment. Okay. Then we'll say awaiting delivery. Okay. Then we're saying complete. Then we're saying disputed in case someone raises a dispute. And then we say cancelled. Okay. So these are the states that I can think of. And what I will do is create. Oh, sorry guys. We say escrow state. Okay. State. Yeah. So we're going to stay hold it all here in the state variable. Now, why we're using enum is, again, we've talked about it, but you can go to our decentralized lottery section to know more about it. But then enums makes the flow very easier to reason about and very safer to use. Now it's about the variables that will deal with amount and timing. So let's see. Okay, we're saying there should be an amount, which is the ETH locked in the escrow. Then there would be deposit time. Deposit time. Okay, this is when the buyer, or this is basically going to track when the buyer made the payment. And then there would be this B. And then there will be a delivery timeout. So in the window, it is like the window in seconds the seller has to deliver, or else, there would be some other scenarios coming in, right? Now we're going to say, okay, now that we've talked about address and then certain variables, even enums, we are still left with the event section. So we will say, okay, there could be one event which says payment deposited. Okay. And we're saying address, index, user, who's actually buyer. And then we're saying UINT 256 amount, right? Now let me just copy this and think of what, by the time I do that, think of maybe other sections. Five is enough, right? Maybe I can say, one event could be delivery confirmed, right? So what would we need there? There would be an address of the buyer. There would be a seller here. And then okay. And there would be an amount, right? Now here with dispute raised, maybe in case there's one section, we will say who is the person who raised the dispute. So we will say, okay, the address should be of the initiator. That's it. That we don't need anything else here. Then if it's dispute raised, then there should be a dispute resolved. Okay, now in the dispute resolved, we know that there's a person existing as arbiter, then there's a recipient, and then there would be an amount, because once the dispute is resolved, some money will be given out, like whatever is the pending amount or whatsoever. So there would be an arbiter, then there would be address of the recipient. Yeah, and then there would be an amount, right? Oh my God, everywhere I've written amount here. Okay. Now that you've talked about dispute resolve, what is it? There could be a cancellation that happens, right? So escrow cancelled. Okay. Now this would also be only dependent on, who the initiator is. Yeah, that's it. Now, okay. Probably one more which says delivery timeout reached, right? So that has to be for the person, who's buying product. Again, like you have to deliver in this time and make sure that you also give out the money. So we're saying address indexed buyer. Great. So all of these are pretty simple. With payment deposited, confirm that the escrow has started, show the logged amount in the front end. So that is where it can be used. With delivery confirmed, we're saying, hey, this fires when the buyer confirms that they've received the product or the service. So it can be used to confirm the completion of the transaction, indicate that the seller has been paid. Then there's a dispute raised again. Fires when maybe the buyer or seller raises a dispute, so it can notify the front end and possibly trigger a UI change like dispute in progress. Let the arbiter know that their attention is needed. With dispute resolved, again, if everything is solved, arbiter resolves a dispute and the funds are transferred, then we would need the arbiter, the recipient, and the amount. Again, it could be used to show final status of the dispute, maybe display who got the funds and how much. With escrow cancellation, anybody can cancel it either through timeout or mutual agreement whatsoever. So you can update the UI with escrow cancel status, indicate a refund has been issued. And with delivery timeout reach, it's like if the buyer cancels after the delivery window expires. So it could be used to show timeout reason, explain why funds were refunded automatically and all of that. Now that we've written these events, it's time to write functions which will bring this escrow live to logic. Okay. So the entire step around, okay, we don't need this here. Just noticed. Yeah. So the entire step of the escrow process has to be clearly mapped out so that you don't miss out on anything. So the first could be the buyer deposits ETH in the escrow, the seller delivers and the buyer confirms. Then if there's trouble, either party can raise a dispute. The fourth could be that a neutral arbiter steps in to resolve conflicts. The buyer can cancel if the seller takes too long, and either side can mutually walk away, right? So we will just get started, but before we actually write the functions, we will get to write the constructor here. It's very important. So we're saying constructor. Okay, now what is it that we need? We've already declared some immutable sections here. So we will say address of the seller, because buyer is automatically the person who is deploying the contract, right? Then we're saying address of the arbiter, and then UN 256, whatever is the delivery timeout, like for whatever long you want this to, sort of run. Okay, great. So there would be a required condition that the delivery timeout should be greater than 0. Obviously, the time has to be greater than 0. Otherwise, you put a condition that timeout must be greater than 0. Right? Now, once this is done, all you're going to do is, initialize these values. So we say buyer is equals to message.sender. Seller is equals to underscore seller. Arbiter is equals to underscore arbiter. What was it again? Delivery timeout is equals to underscore delivery timeout. And then there's a state thing. So we say escrow state. Okay, dot awaiting payment, right? This is the natural value that we are going on with. This is how we're going to set the entire thing. Now, there's nothing to explain here except the fact that we start the contract in a waiting state because funds haven't been deposited yet. And this ensures that the deposit function is the next logical step, and any other action like confirming delivery and all of that is blocked until this happens, like until the deposit happens, right? Now, with the delivery timeout also, we know that the time window has been set for in which the seller has to deliver, measured in seconds. So it starts ticking only after the buyer deposits ETH into the contract. We will later use this in the case cancel after timeout function to let the buyer cancel the deal and get a refund if the seller delays. Okay. Now, we generally add it towards the end, but there should be, because we're dealing with ETH here, there should be a receive function, external payable. Now, this will say that, okay, it will revert direct Okay, so this little function here is to act as a bouncer at the door for your contract. It blocks any ETH that someone tries to send without calling the correct function like deposit. Now, you might be wondering that why do we need it at all? Isn't all ETH sent to a contract just part of the normal flow? Not exactly, okay? So by default, any smart contract in Solidity can receive ETH very silently, even if the sender does not call a specific function. That is where we're using receive. That means someone could go to Etherscan, paste in your contract address and send ETH to it without interacting with the carefully written logic here. And that is where the receive function comes in. In Solidity, this function is called automatically, as I mentioned, whenever the contract receives ETH without any data. So you have to be very, very careful, right? Now we want every deposit to go through a proper channel, which is a deposit function where we track who sent it, then update the amount, change the state, record the timestamp, and then emit an event. So all of that is skipped if the ETH is just sent blindly to the contract, right? So that is why we reject it. So we're saying if someone's trying to submit or like deposit ETH directly without using this, the receive function, instead of accepting it, will just reject it. And this is just to make sure that no ETH accidentally enters the contract without handling it, and everything is, done through the contract. Okay. Now that we've talked about it, we should get writing the function. We're saying function deposit, nothing here. It should be external, payable, great. Now, few conditions to check require message.sender equals to buyer, right? Only buyer can deposit. Great. First condition, that require state is equals to escrow state dot awaiting, not delivery, payment, right? Now, why are we doing this is because only if it is in that state, you can call this function. Otherwise, if the deposit is made, then maybe you're waiting for delivery or completed. So you have to make sure. Otherwise, if it's in this state, great. Otherwise, it says, hey, it's already paid. So you don't make deposits twice. Then you check, hey, is the deposit, that is message.value, greater than 0? If yes, great. Otherwise, amount must be greater than 0. Okay. Now we've checked 3 conditions. All we have to do is we say amount is equals to message.value state. Because the deposit has made, the state needs to change. So we will say escrow state dot awaiting delivery, because the deposit has been made. Obviously, then it's time to, that is where the clock starts ticking in and the person has to the person who's selling has to deliver in that time, right? Deposit timeout will be again block dot timestamp, because that is where, from where the counting starts. And then we will say, hey, emit payment deposited, the buyer and the amount. Yeah, that's pretty much it. Now everything is self-understandable. This function is basically allowing the buyer to lock it into the contract and yeah, just go about it. Okay. Any confusions, you can definitely ask us in the group. But right now we will just get to the next function. Now the deposit is made. The next thing is the state is in awaiting delivery. So we will write a function confirm delivery section. We'll say confirm delivery, right? And we say external. Okay, we will save our time with this a little bit, right? And we say, okay, this has to be awaiting delivery. Capital delivery. Okay. And here we can just say that, hey, not in delivery state. Okay. So you are checking message.sender is buyer, only buyer can confirm, not deposit, confirm that he or she has got the delivery, and then you will check the state. Now, once that is done, you will just update the state to complete. Okay, because the delivery is now done, right? And it's time that you send the payment to the seller. Sorry, every time I write enums, I don't know, I do a lot of caps mistake. Yeah. So we say payable, and who's the person? Then the seller would be the person, because he or she is supposed to receive it, and dot transfer amount. And once you do that, you say emit delivery confirmed, buyer is buyer, seller is seller, amount is amount. Great. So once the buyer has received it, go ahead, release the funds. That is what is happening here. This function will finalize the transaction, transfer the logged ETH to the seller. That is where the transfer function, operation comes in and updates the contract to show that, everything is done. Okay. Now that we've written the confirm delivery function, we've also talked about deposit. What could be a possible scenario? The possible scenario could be maybe the seller didn't deliver. Maybe the buyer is claiming that they didn't receive them. So there can be a dispute scenario here. So we will just say function raise dispute. Again, external, right? And we're saying it could be done by both parties. So we say require. The condition is either the message.sender is equals to a buyer, okay, or the message.sender is the seller. Okay, these two people can raise a dispute. Okay, apart from that, it would be not authorized. Okay, so we're adding like a mutual section where they can raise a dispute, and we have to say the state could be is escrow state dot awaiting delivery. Okay, because if this is the state, great. Otherwise, we will say can't dispute now. Like if the person has marked it completed, then you can't just raise a dispute. You have to make sure that it is in the awaiting delivery state that the seller will or the buyer would actually talk about it or raise it. And then we say state is equals to, we just say escrow dot state disputed, great. And then we say emit dispute raised, and then initiator, whosoever is the message dot sender. What is the problem here again? Oh, we have missed equals to here. Just silly mistakes that we really do. So now, so now we understand the motive behind what a raise dispute is for. So when trust breaks down, we need a way for either party to raise their hand and say something's wrong, right? So it is when the escrow would be put in a disputed state, when no funds can be moved, and signals the arbiter that their attention is required here. Now, if we have written this raise dispute, there would be a resolve dispute section, obviously. Right? Oh my God. Okay, let's just play around and see what do we need to change here, right? So first of all, I think with resolve dispute, we would need a Boolean value here, which says, hey, you know, what is going to be actually like, we can put a Boolean value which says, oh, should we release the payment to seller or should we not, right? Because that's how the dispute, like that is going to be the output of it, right? So no, since we're saying that if it's in a dispute state, no funds can be touched until someone neutral steps in. So that neutral party would be the arbiter. The arbiter job is to review the situation and make a final decision. Should the seller get paid or should the buyer be refunded? Okay. So if we set up something like bool release to seller, then if it's false, then the buyer gets refunded. Otherwise, it says, okay, no, the seller is supposed to, you know, get the money, right? So that is one thing. So we have, okay, we will make changes to what AI has told us because, yeah, let's see, you know, what can actually go wrong here. But one required condition that AI is definitely missing is that message.sender has to be an arbiter, right? Because only arbiter can resolve. Okay, great. Now, once you've done that, you will check if the escrow state is to disputed, otherwise no dispute to be resolved, right? Now, okay, this entire thing needs to go. Why? Because we will go step by step understanding what is the requirement here. So once you have checked these conditions, right, it has to be, if it is, you know, something that needs to be solved, after that, it will go to a complete state. And there's a if condition which says if release to seller, right? What happens? Then we will say, hey, let's make the seller a payable and dot transfer the amount. Okay, great. And then emit dispute resolved. Again, arbiter, then here would be the seller and then an amount. If not, right, the buyer is supposed to get refunded, right? So we will say payable buyer dot transfer amount and we will say emit dispute resolved, and here the recipient would be the buyer. Okay, this is what we're supposed to change. Okay, so the dispute is raised. Using raised dispute, the escrow is frozen, no one can touch the fund, the neutral party is the arbiter, and everyone's deciding that, hey, is this is the fund supposed to go to the seller or is it supposed to get refunded to the buyer? Now there is a require statement which checks who the message or sender is. The other is where we check what is the state, okay, for that particular moment. So the function can only be used when the contract is in the disputed state, no other time. That means you can't call this before a problem has been raised, right? Or after the deal has already been completed or cancelled. So now, no matter what the decision arbiter makes, the escrow is now closed. So this prevents any further actions like cancelling or disputing again. And that is why we're changing the state to complete and locking the final outcome into place. Now, releasing funds based on decision, very simple. So the arbiter is passing in a Boolean value, true and false, and based on that, it says if it's true, the seller gets the ETH. If it is false, then the buyer gets the ETH back, right? And that is how the entire dispute is resolved, okay? Now, because we have talked about, okay, this is here, right? Now, we've dealt with dispute section as well. So now, again, it should be tag. Great. Now we will write a function called cancel after timeout. Okay. This is like emergency exit as a buyer. Let's say you've logged your ETH in escrow. The seller was supposed to deliver something, but days go by, nothing shows up, no delivery, no communication. Rather than being stuck with your money forever in the contract, this function gives you a way to back out, but only if agreed upon the deadline, right? So if I say that, hey, I am putting a timeout for 5 minutes, 300 seconds. Now, I can only call or call this function, which is cancelling, once that 5 minutes has passed, right? Because the decided timing was that the seller might deliver in 1 day or 2 days. Imagine you are freelancing, right? And you said that the project is to be delivered in just 3 days. And the buyer just rushes and tries to cancel in just 1 day. It is not fair, right? You've started working and all of that. So that is why we'll put an option which says cancel after timeout, which checks the condition that is the decided time duration over already? If yes, then you can back out, like take your money back. Otherwise, you have to wait, right? So we say, okay, and that's external. Okay. Now, check a few conditions. I'll just copy it from here. Or maybe from here. Okay. So we're saying require message.sender is equals to buyer. Oh, shit. Yeah. Only a buyer can trigger after timeout, right? And then it says, hey, you also have to check if the escrow.state is awaiting delivery. Cannot cancel in current state. Like whatever else is the state may be complete or whatsoever, you can't cancel it. Now it will also check another condition which says require block dot timestamp has to be greater than equals to deposit time plus the delivery timeout, because that is the total time. If yes, great. Otherwise, it says timeout not reached. Fair enough, right? For everyone. And then if that happens, we will take the escrow state dot cancelled, because we are cancelling, and we will refund it to the buyer, payable buyer dot transfer. Again, we're transferring from the logged amount, so we say address this dot balance, whatever was in the escrow contract, whatever was logged, right? Whatever buyer paid. And then we have to emit escrow cancelled. The initiator here is the buyer. And there would be another thing which is emit delivery timeout reached. Again, it's by the buyer, right? So very, very simple function. You know what happens, how the state is happening, make sure that the timeout is reached, and with whatever was logged in the contract, that is transferred to the buyer, and two events are emitted again. Escrow cancelled and a delivery timeout. Okay, now since we've given the buyer an upper hand, it's also fair that some situation might arise and both parties decide to, call off the deal. No disputes, no timeouts, no drama, but maybe the seller just can't fulfill the order anymore. Maybe the buyer changed their mind, or maybe both sides agree it's just not going to work out, right? So this function will allow both the buyer or seller to cancel the escrow. So it has to be a mutual thing, right? So we have to say function cancel mutual, right? Now we say external. Okay, again, just go here. We are saying, okay, required conditions, either the message.sender is a buyer or the message.sender is a seller, otherwise no one else is authorized. For the required state, the escrow state has to be in awaiting delivery or awaiting payment. And then you can say can't cancel now. Okay, now obviously, like maybe the buyer decides to back off or the seller decides to back off or whatsoever, both of them should get a chance for that, right? Now what we will do is whatever was the previous state, we're saying escrow state, previous state is equals to state, because something was initiated here but then they decided to cancel, so we have to revert back. And then we'll also update the escrow state dot cancelled. Okay, now two conditions to be checked. If previous state is equals to escrow state dot awaiting delivery, right? Then what happens? Obviously, just the delivery was left, right? That means the funds have been logged into the contract. So we will do buyer dot transfer, address this dot balance. Always the wrong. Right. Yeah, great. Otherwise, you can just say emit escrow cancelled, and the initiator is the message dot sender. Okay, because the seller is anyway not supposed to receive the money. So again, this logic is very, very simple. Either the buyer or the seller tries to cancel before it's completed. So you have to check for two states, either delivery or payment, and then just go about. You guys might be confused on the escrow state, previous state is equals to state. Again, to explain that, we are storing the current state in a temporary variable, so we can check later if the funds were already deposited. Why does this matter? Is because if you're canceling after a deposit has been made, we need to refund the buyer. So we will store it there and then set the state to cancelled, and that is the temporary variable. In this case, it's previous state, and we're checking that it's time that, if it was in awaiting delivery, then the buyer has already deposited it and we need to refund it. This ensures that the seller doesn't walk away with funds from an incomplete or cancelled transaction. If the state was still awaiting payment, the condition is skipped because no money was ever deposited, and then, just get it. Now, time for some utility function. We say I've set a timeout time, but I want to see how much time is left before I, can exit, or after I can cancel, whatever. So we say view returns uint 256. And yeah, we go about checking the condition where we say, okay, if state is not equals to escrow state dot awaiting a delivery, then just return 0. Okay. Otherwise, we can just, oh, not require. It has to be an if condition. Sorry, guys. Yeah. Otherwise, we're saying also if block dot timestamp is greater than equals to deposit time plus the delivery timeout. Come on, delivery timeout. Then also you will return 0 because the block timestamp is already ahead of whatever was decided, right? Otherwise, you will return deposit time plus delivery timeout, okay, minus block dot timestamp. Yeah, simple utility function, only read-only helper design probably to be used in the front end. So with the first condition, we only care about what time left while we are waiting for delivery, right? So if we are in any other state, like waiting for payment, completed, disputed, cancelled, there's no countdown happening. That is why we're returning 0. The next two are very, very simple for you to actually understand. Okay. So that's pretty much it on the implementation side. Let's just see what happens here. Okay. So we're saying there's a seller, there's arbiter, there's a delivery timeout. So I will copy this contract address because buyer is obviously message.sender. So I'll say, okay, the arbiter would be another contract, right? For B2. And for delivery timeout, maybe I'll just put 600 seconds and I will transact. Okay, great. Now this happens, fine. Now, state 0, that is the first one awaiting payment, right? Who's the seller? This person is the seller. Get time left, 0, because right now nothing is started. Deposit time, 0, we have not deposited yet. Delivery timeout is set to 600. The countdown has not started because it will only start after you've made the deposit. Buyer, this arbiter, this amount, 0, resolve. Okay. So it's time that now I deposit something. So I will just set this to third and I will put in 2. Okay. Now I made the deposit. Okay. Now if you see deposit time is set, get time left. Now certain seconds are there. Okay. Now this is the balance here. Now, maybe I say, can I, okay, I will come here and then I say confirm delivery. What will happen? Only buyer can confirm, right? But then we'll say maybe cancel mutual, right? Now this balance becomes 0 ETH and the money comes back to the buyer, right? Now, maybe let's just go here, deposit 2 ETH again. Okay, I've already paid, but then that was cancelled, right? So then it will not happen. Okay, great. So for this thing for this setup, it has worked fine. Now maybe let's try to redeploy. Okay. We'll close this one. We'll transact again. Great. This is our new contract. So again, I will deposit maybe 3 Ether. Oh, 3 Ether. Everything else here is the same. Buyer, delivery time, etc. So I deposit it. And then, even though I have some time left, I will say, okay, the seller has, given me the money. So right now, this has 99. Let's see what happens. This is gone and this becomes 102. So 3 ETH is sent to the seller. Voila! So nice. Now, similarly, you can okay, we'll have to redeploy again to maybe see the dispute section, or maybe you can just try around on your own. Let us know if it should work. But let us know if you have any questions, or maybe I should just deploy it with the shoe, right? This time I will put 4 Ether. Now, there are different scenarios, right? Confirm delivery. Yeah, this is the new one. So this time I will deposit maybe a 5 Ether and I deposit. Okay, and then I raise a dispute from the seller's account. So I say, okay, no, wait, how did we write the raise dispute? Awaiting delivery. What is the state of it? It's awaiting delivery. And then okay, so the raise dispute here from this account has happened. The arbiter would come in, right? And then I will say, hey, you know what? I don't want it to be released to seller because the delivery has not been confirmed or whatsoever. So the arbiter will come. Release to seller, we will make false. So you will observe this. This is at 91. This is at 102. If seller was supposed to get it, it would become 107. If this is supposed to get it, then it becomes 96.99. So I say arbiter that no, don't release to seller. So then this become 96.99 because the buyer will get it. So yeah, everything's working fine. So that's pretty much it. We've added a lot of possible scenarios in the text-based solution, so you can experiment with that. And we've built, a good, secure, transparent, and self-enforcing escrow system. Now you are much experienced when it comes to roles, access controls, enums, timeouts, disputes, events, everything, right? Now, if you want to know about what real use cases you can build from here, freelance marketplaces, NFT or digital good trades, community bounties or grants, crowdfunding with conditional payouts, even DAO controlled dispute resolution systems, all of it, right? So escrow is everywhere, and now you know how to build it from scratch. So good work, all of you guys, and I will see you on day 25. Till then, keep building, people.